Okay, today we're going to have a look at limits. And we're going to have a look at this equation here to start with. And we're going to look at what we can see with this. And this is a really interesting equation. So we're going to just make a little table of values and see what comes out with it. So we have x and f of x. So we start with a -2, -1, 0, 1, 2, 3. Put that in there. So we start off with -2. -2 squared is 4. -6 is -2, plus 2 is 0. 0 over -2 plus 1 is -1. 0 over -1 is 0. Right? We're going to skip -1 for the second. We'll come back to that in a second. We'll put 0 in there. That becomes 2 over 1, which is 2. We put 1 in here. That becomes 1 plus 3, which is 4, plus 2 is 6 over 2, which is 3. Then we're going to look at putting 2 into here, so that's 4, plus 6 is 10, plus 2 is 12. 12 over 3 is 4. Right, 3 in here is going to be 3 squared is 9, plus 9 is 18, plus 2 is 20, over 4 is 5. Right, and so we can see there's a bit of a pattern here. Sorry, forgive my writing, this is not working how it should do. Right, there's a bit of a pattern, and we could expect this one here would be 1. But let's put the numbers in and find out. So, if we put this in, we're going to end up with -1 squared plus 3 times -1, which is -3, plus 2, all divided by -1 plus 1. So we should get 1 minus 3, which is -2, plus 2 is 0, over 0. Now 0 over 0 is a bit of a tricky beast because it doesn't actually exist. This is undefined. And so if we were to draw a graph of it, it would end up looking something like this. Right. The line would go through at -2, 0. It would go through at 0, 2. And then there would be a gap in the line. Because it would not be, there is no point where x is -1. It's undefined at that point. X cannot equal -1 because this would be 0. We can't have a 0 on the denominator. However, we can say what happens when x gets really, really close to -1. So what if x was, for example, -0.99999. Well, let's have a look. If that was the case, then we're going to end up with it getting very close in f of x. Very close to 1. And so we can actually write there's a way of writing this that that describes this. What we say is this. The limit as x approaches 1, negative 1, of x squared plus 3x plus 2, all over, it should be plus 2, all over x plus 2, sorry, it's x plus 1, equals 1. It's saying that while we don't know what it is when x equals negative 1, we know when x gets very close to negative 1, it gets close to 1. Right. We can't know exactly what it is because it's undefined, but we can assume that it's 1 for the sake of most purposes. And that's what a limit is. Okay, let's look at why that works. So we had our top part of the equation, which was x squared plus 2x, plus 3x plus 2, all divided by x plus 1. Now what we can see there is that top part of it actually will factorise. So the top part of it will become x plus 2, x plus 1, all divided by x plus 1. And so we see there we've got something that we can cancel out, which leaves us with x plus 2. Now the problem is that that works for every point except for 1, because the one time you can't cancel out x plus 1 over x plus 1 is when x equals negative 1. So it doesn't work where x equals negative 1, but we can say that for every other point it works. So when x gets really, really close to negative 1, this big equation over here, this big function here, will get very close to 1. And that's why we can do that. Right, so anytime we see something that can be factorized like that, we can do that. And we just have to remember that it's not that f of x is not equal to 1 when x is 1. It's just the limit as x approaches negative 1 is 1. Right. We can have a look at a different type of equation. Let's have a look at one of these. Okay, let's look at this function here. X plus 3 over x plus 1. We should probably put in a f of x equals. Right. Now, this one it's a hyperbola, and it's got a couple of asymptotes. So we could draw it, but the interesting thing here is what happens when x gets really close to infinity? Right. What does it become? And so we're going to look at it, and we're going to draw a little graph of it to show what it looks like, and we're going to plot some numbers and have a look at it that way. So first of all, let's take a few numbers that we can use. So we're going to start with 0. All right. When x is 0, we've got 3 over 1, which is 3. When x is 1, we've got 4 over 2, which is 2. When x is 2, we've got 5 over 3. When x is 3, we've got 6 over 4. When x is 4, we end up with 7 over 5. When x is 5, we get 8 over 6. And then why don't we put in a big number into it? Let's put in 100. Right? Well, if we put 100 in here, we're going to get 103 over 101. Well, let's do 90. Let's, rather than 100, let's use 99. We use 99. This is going to make nicer numbers. So it's 1.02. What's it getting close to? Well, it's getting close to 1. And if we were to draw it, our graph would look something like this. Of course, it's going to look something like that. With our other asymptote being at negative 1. All right. So what we can see is that the limit as x approaches infinity of x plus 3 over x plus 1 equals 1. It's going to keep on getting closer and closer and closer to 1. Right? And that's actually kind of useful because it means that that we know where it gets to, and that's the idea, is that we want to know where it's heading towards. So if we put a really, really big number, and let's say 100 million, we would be really, really close to 1. Right? And that's sort of what we're wanting to find out. Now, it turns out that when we get a really, really big number in, what's going to happen is that anything that's been added onto it becomes irrelevant. So this just becomes 1 over 1, or 1. If instead I had one that looked like this, if I wanted to know the limit as x approaches infinity of 4x minus 3 over x plus 2, well, when we get close to infinity, this minus 3 and the plus 2 are going to just become irrelevant. So the limit is going to be 4 lots of infinity divided by infinity. 4 times infinity divided by infinity, which is 4. Now, of course, we can't divide by infinity. It's not something that we're actually able to do. But in this situation, we're not saying that it's going to equal 4. We're going to say it's going to get very, very close to 4. And so our limit equals 4. It becomes 4. And that's how we do a limit to infinity. We also can see a situation where we have something like this. X over 3 to the power of x. Right, and if we wanted to know what the limit was as x approaches infinity, well, it's going to be hard to put in 3 to the power of infinity. It's not something that we really know how to do. It's going to be an infinite number. So what we could do is we can put in a really big number. So let's put in 100 to this one. So we're going to become, so it would be 100 over 3 to the power of 100. Now, if we bang that into our calculator, it comes out to a number like this: 1.94 times 10 to the power of negative 46. In other words, it's 46 zeros before we get a 1, and 45 zeros before we get the 1, 0.45 zeros, and then a 194. Now, obviously, that's a really, really, really small number, and it's starting to get very close to 0. So we can suggest from that that equals 0. Now, we might want to try putting 1,000 in and just see to make sure it doesn't go below 0, but effectively we can use a big number, and if we were even just take a number, take a couple of numbers will give us a fair indication. All right. So we've got 3 ways of doing it. We've got the factorizing way. We have the that's the first way. The second way we looked at was where you substitute infinity, and then you can cancel them out. And the third way was the big number way for finding the sum to infinity.